So in the previous part of this module, we sent and received text messages. We'll now take a look at sending and receiving binary messages. So what we're going to send is a file. So we'll allow the client to upload a file, maybe to use as an image of themselves, maybe an avatar. And we do that through the page. So on the index page, we have an input field, and this input field is of type file. So that allows the user to select a file and then store that file as a reference inside this field. And we'll pull out that file reference and send that reference to the client. The code to do that is in our chat view model, and here we have an upload image helper, and this upload image creates a file reader, which is part of HTML5, calls read as array buffer, passing it a reference to the element on the screen which contains that file, grabs the data inside the onload event for this reader. The onload event fires after the file's been loaded into the browser. And then we have a helper function here called sendBinary. That sendBinary is our code. That will send the binary data over the socket. It's a very simple function that we need to write as part of this module. Handling binary messages is in some ways similar to handling text messages. We add another onMessage handler here. And again, this will be a public void method. But in this case, we need to let the runtime know that we're going to handle a binary message. To do that, we pass to this something called a byte buffer. There are various ways of doing this, but in this case, we'll use a byte buffer to handle the data. So we can call this byte buffer. And then we also need to let the runtime know that this will be a partial message. And the way we do that is by passing a flag here. It's used to tell us whether or not the upload is complete. So the way that the partial messages work is that when a message comes in, part of that message is delivered to the onMessage handler through the byte buffer in this case, and that Boolean flag is set to false. When the final part of the message comes in, we'll get given that final piece of data, and this complete flag is set to true. Notice here we have some red squiggles on the page. This is simply IDEA not recognizing that we in fact have messages for both string and binary. And the warning it's giving us, if I hover over this, is that there are multiple onMessage methods handling text messages, which is not the case here. So to handle this binary data, we need to extract the data from the incoming byte buffer and store it somewhere until we get the complete flag. And then we can send out an update saying that we have this message, or we can process the message that we have in some other way. To do that, we'll create a byte array output stream where we'll save this data. We'll simply call this buffer, and we'll create a new byte array output stream. So inside the onMessage handler, we'll simply write to the buffer. The byte buffer has an array method that allows us to extract the underlying byte array, and we can just simply write that byte array into the byte array output stream. So I can say buffer.write byte buffer.array, and that will write the incoming byte array into our buffer, and we can process that at a later stage. Notice again that this is warning us that we have an exception here, so we'll simply surround our call inside a try catch. Once we have that, we can then add a check to see if this is the last call. So if complete, and that's simply a Boolean value. So if it is complete, we want to maybe broadcast a message. So again, I'm going to be very naughty here, and for now copy this code. We can refactor this later into a separate method, and in here simply send out a message saying that the call is complete. And I'm going to send a JSON message, which will be something like call colon think about this / complete. something like that, I believe. So once we have that, the server side of the call is done. So just to recap, and we will put some breakpoints in here. I'll do that now, so we can see this in progress. So once we do this, this method, the onMessage handler, will be called multiple times. Each time it'll be passed a byte buffer, and that byte buffer will contain part of the data. The final time it's called, the complete flag will be set. At that point, we have a complete buffer, and we have a complete byte array output stream, and we can send a message to the client telling it that the data has been received. Again, in this case, we're going to broadcast the message. There's probably no need to do that, but we already have that code in place, so we'll use that to send out all the data. So from the client's point of view, we need to send the data as binary. So if we look in our chat view model code, we have this send binary helper. That is a method on our chat code, which is in chat.js, and we don't have an implementation of that yet. So here we can say send binary. That's the method that we were calling from chat view model, and we'll call that send binary as well. And the reason we're doing this is that our send message helper here calls this function, and this function is taking the data we pass into it and calling json.stringify. So we're passing up text data. So for our send binary, we simply don't need to do that. So we can copy and paste this. Again, not best practice, but it will do in this simple case. So send binary. And here we're simply going to send up the message. One thing to notice before we start the demo, and I've just noticed this, is that the onMessage handler here, the type at the end for the complete, must be Boolean with a lowercase b, not Boolean with an uppercase b. If we try it with the uppercase b, then the application won't start. It'll think instead that we have two message handlers for string messages, as it won't recognize the signature of this method. So we can now run the application. I've set a couple of breakpoints here inside onMessage. One when we simply get onMessage called, being passed the data, so we can see this thing being called many times, and then one inside the complete handler. If we go into the browser and bring up the console, we can see that we've connected. Okay, I'll clear this console, and if I go to the sources, we have some breakpoints set. One when we click on the upload image, which is this button here, and then one when we're going to send the data. If I set one here as well to show us calling this read as array buffer. So when I click on choose file here, we get a file dialog. I'll just pick a JPEG and open that up, and then we can click on upload. So we hit this upload image function. We create a file reader. I just leave that run. We call read as array buffer. So again, I'll leave that run, and we hit the onload handler. So inside here, result is an array buffer, and that contains the data we're about to send. And inside here, we're calling the send binary helper. So we step into this send binary code. In here, we check to see if the socket is valid, and if it is, we simply send the message. Again, the message is the array buffer to the server. So if I hit go, that will allow us to hit the breakpoint in the server. And indeed, we're inside onMessage. And here we have a byte buffer. If I hover over this, we can see this byte buffer contains 8K, 8,000 bytes of data. And this will be called several times. So I'll leave this run. There's 2, 3, 4, 5 times. So finally we come out of this, and our byte array output stream contains all the data that we need. And once we have that, we broadcast the fact that this was a successful call. And if I go back to Chrome, then in here in the console, we see the message, so call complete, so very simple. So I suppose we have one last thing to check, and that's that the binary upload is actually uploading the correct data. We'll do that by selecting a file, an image, and then saving that image to disk and taking a look at the image. So inside our onMessage handler, inside the complete call, we'll create a file output stream, call this FOS, and just do a new file output stream here. And we'll store this on my C drive, and we'll store it in the temp directory, and we'll just give it a name of image.jpg, and we'll make sure we upload a JPEG to do this. We'll surround this in a try finally, just to make sure that we properly close the stream when we finish with it. So we'll use IntelliJ here to do some of the lifting for us, move this outside the block, and then inside here we'll call fos.close, and before we do that we'll call fos.flush. And make sure FOS is initialized here, and I guess we should probably put a check in here to say if FOS is not equal to null, then flush and close. And finally inside here we do fos.write, and we'll write out the buffer that we have. So that's going to be buffer.2byte array. So once we have that, we make sure the code is redeployed. Make sure there's no file in that folder, and indeed that currently has no file in it. Go to the browser, refresh, make sure we've joined, then select a file. So we'll pick kevinhead.jpg and upload that. No breakpoint set here, so that file should have been uploaded. And indeed there's an image.jpg here, and if we open that up, then the image looks like it's been uploaded correctly.